Alrighty, welcome back, boys and girls. It's your main math man, Shane, coming to you live from Summit Academy. In this video, what we're going to be working on is that unit number 7, lesson 5. Still talking about exponents, but we're going to be able to use those exponent rules for negative exponents now. And it says for the first part, it says what's that exponent? So it says solve each equation. And so what I can do is kind of use some reminder ideas that we had from before. We said that we had a base, and then the exponent was attached to it, and that's a little bit higher on the when you're writing it. So we're saying, okay, if this is our base and this is our exponent, we're trying to figure out, what is x in this first one. So it says 100 divided by 1 is equal to 10 to the power x. Well, if we say separately that we know that 10 times 10 equals 100, that also means that 10 squared is equal to 100. So we can say for this one, 10 squared tells us that x equals 2 for this one. Then for the next one, it says 100 divided by x equals 10 to the first power. So we could say, well, fill in some blanks, 100 divided by 10 is equal to 10, which is the same as 10 to the first power. So we can just say x equals 10 for this one. Moving on to the second one, we have x divided by 100 equals 10 to the power 0. Again, make sure you remember 10 to the power 0 is equal to 1. And we could say that's equal to 100 divided by 100. So we could say x is going to be equal to, let's say, you can say x is equal to 10 squared, which is the same as 100. Either way works. And then for the last one, it says 100 divided by 1000 equals 10 to the power x. Well, if we remember our exponent rules before, when we were dividing, we said, okay, if we have 10 squared divided by 10 to the third power, we would subtract those exponents. So that means we just have to say that we have to have 2 minus 3. So we're going to have that this is going to be equal to, when I say 10 to the negative 1 gives us x equals negative 1 for this case. So notice how some of these are similar and some of these are different. And so that's what we're going to be mainly working with today, is those negative exponents. So the next part says complete the table to explore what negative exponents mean. So if you look at as you're moving to the left, we're multiplying by 10 each time. And if we look at these ideas, we're saying that, hey, what happens when we have, if we move to the left, our exponents are increasing. So we're multiplying by 10 each time. So that means if we go down, we can say something like this. Hold on, give me 1 second. So we're saying as we move to the left now, we're decreasing that variable. So we're that exponent. So we're going to say it's going to be 10 to the power 0. When you decrease it more, we're going to say 10 to the negative 1 power, 10 to the negative 2 power, 10 to the negative 3 power, so on and so forth. So notice how, as we move to the left, it's like we're multiplying by 10, we're increasing that value. As we move to the right, we're decreasing that exponent, so we're decreasing that value. So if we were to write it as a decimal, notice how you can count the number of zeros. So you're saying, you have 1, 2, 3 zeros ahead of the decimal. So that same idea, we can say this is going to be 100. This is going to just be 10. We have a non-zero number to the power 0 is equal to 1. So we just have 1. And now this is where we move the decimal to the left. So we're going to say that we're saying this is going to be 0.1. This is 0.01. And now we can say how many total zeros do we have? We have 3 total zeros. So we have 0.001. So you have 1, 2, 3 zeros there. And then if we were to write it as a fraction, we can say, okay, we have 1000 divided by 1. We have 100 divided by 1. We have 10 divided by 1. 1 divided by 1. Now we're going to say 1 divided by 10. 1 divided by 100. and 1 divided by 1,000. So notice how these patterns are working out for this table. And so for that first question, it says as you move toward the left, each number is being multiplied by a 10. What is the multiplier as you move to the right? So notice how that has a question mark there. And what we can say is this. We can say as you move to the right, we could say the multiplier is 1 over 10. So as we move to the right, we're multiplying by 1 over 10. So that's why it's almost like we are dividing by 10 as we move to the right. So for each of these, we are multiplying by 1/10. All right. So still working with the same table, we have other questions that go along with it. So it says, how does each of these multipliers affect the placement of the decimal? So a couple things we can write with this one. We can say the first part. So we're going to say for that first part, we can say in orange here, I'm going to say multiplying by 10 results in the decimal point shifting one place to the right. So it's like, we have, do an orange here, it's like we have 10 to the power 2. It's like we're moving that decimal place. We circle it, move it 2 times to the right, so we're saying 1, 2, fill in zeros like this. So we'd have this is equal to 100. Or if we have a number like this, if we have 10 to the negative 2, it's like we're shifting that decimal place 2 times to the left. So it'd say this is going to be the same as 0.01. So just make sure you're shifting those back. So it says in green, multiplying by 1 over 10 results in the decimal point shifting one place to the left. So make sure you can move those decimal places carefully. And for number 3, it says use the patterns you found in the table to write 10 to the negative 7 as a fraction. So what I could do is I could write it like this. I can say I have 10 to negative 7 is equal to 1 over, and then I say I have 7 zeros. 7 zeros, 1, 2, 3, 4, 5, 6, 7. So I have to have 7 zeros in my denominator. And I could say this is equal to 1 over 10 to the power 7. So again, notice how if I have the negative exponent, I can get rid of it by writing it as a fraction. So get rid of negative exponent by writing it as a fraction. The same idea for the next one, we could say, okay, if we have our pattern, it says to use our patterns found in the table to write 10 to the negative 5 as a decimal. So I can say, all right, I have 10 to the negative 5. That's going to be the same as 1 times 10 to the negative 5. I circle my exponent. I'm shifting it 5 times to the left. So I'd say like this. I would say this is equal to, I can say I can put a 1 here. I can shift it. I go 1, 2, 3, 4, 5 times to the left, place my decimal place, and fill in the zeros everywhere else. So in total, I should have 5 zeros there, four of which will be after the decimal place. And it says for number 5, it says write 1 divided by 100 million using a single exponent. So what we can do for this one is we can count the zeros that are in the denominator. So I have 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 zeros. And so what that means is I can have 10 to the negative 8 power as our answer. And lastly, it says use the patterns in the table to write 10 to the negative n as a fraction. So just saying, what happens when you have the general form. So it's saying 10 to the negative n is the same as 1 over 10 to the power of n. So to get rid of that negative exponent, you shift it to the bottom. Then it says for the next part, it says match the expressions that describe the repeated multiplication in the same way. So what we're going to say is for each of these we have A, B, C, and D for these. So we use those capital letters, and what we can do is, we have 4 different options that we can choose from. So for that first one, it says 10 squared to the 3rd power. So I have to have 3 sets of 10 squared. And so what I can do is I can say, well, I can have, this is 2, this is 2, this is 2, and so I'm going to say this is going to be A since I have 3 of those 2's. I can cross that one out. Then for the next one, it says B, I have 10 squared to negative 3 power. So that's going to be this first one here because I have 2, 2, 2, and I have that in the denominator. So notice how I have 10 times 10 in the denominator 3 times. Moving to part C, I have 10 to the negative 2 power 3 times. So that's going to be this second option here. So this one is going to go with C because I have, notice how I have 10 squared in the denominator 3 times. And separately, a little bit different now, I have 10 to the negative 2 power to the negative 3 power, and so that's going to be our last option, which is this part D. Alright, then for that part B, it says to write 10 squared to the negative 3 power as a power of 10 with a single exponent. So we're talking about that first option, no, that second option, I should say, this one right here. So this is what we're talking about for this one. We're going to say, let's do change color here. I'm going to say 10 squared to negative, let me say, since I'm raising the exponent, I am multiplying. So I multiply the exponents. So I'm saying 10 squared times, or to the negative 3 power is the same as 10 squared times negative 3, which when I multiply those out, that's going to be 10 to the negative 6 power, which is why when I look at this option, I have that fraction of 1, 2, 3, 4, 5, 6 in the denominator. All right, and then for number 2, it says match the expression, same thing with that repeated multiplication. So we have these exponents. We're saying, okay, for A, B, C, and D, what are going to be our choices? So we could say for that first one, we have 10 squared in the numerator and 10 to the 5th power in the denominator. So I have to have 2 10s in the numerator and 5 10s in the denominator. So I'm going to say this one goes with A. For part B, I now have 10 squared, so I have 2 10s in the numerator, and then I have 5 1/10s in the denominator. So I'm going to say for that second one, I'm going to say this one's going to be B, because notice how I have, again, 1/10 is the same as 10 to the negative 1 power. So we have to have that 5 times in the denominator. All right, so that was choice B. And for choice C, we have 10 to the negative 2 divided by 10 to the 5th power. So I'm going to say we have 2 fractions in the numerator, and then we have 5 10s in the denominator. So that's going to be that third choice. And lastly, but certainly not leastly, we have 10 to the negative 2 power divided by 10 to the negative 5 power. So we're going to say for that one, we're going to say that's going to be D, which is this first option. So notice how I have 10 to the negative 2 and 10 to the negative 5 all split by that fraction bar in the middle. So this is that option that we're going to do for this part B, is we're going to say write 10 to the negative 2 divided by 10 to the negative 5 as the power of 10 with a single exponent. So what we do when we divide those values with the same base, we subtract the exponents. So what I'm going to do is I'm going to say I have 10 to the negative 2 divided by 10 to the negative 5 is that going to be the same as 10 to the negative 2 minus a negative 5. Again, be careful when you're working with these integers. It's almost like we're adding 5 to it, so we're going to say this is going to be the same as 10 to the 3rd power. You can say check using Desmos. Either check the first original one, or you can check that exponent to make sure that is subtracted carefully. Then for number 3, it says match the expression that describes the repeated multiplication in the same way. So same kind of setup. We have A, B, C, and D. What we're talking about when we are multiplying numbers with the same base, it's almost like we're adding the exponent. So we'll talk about that here in a second. So it says 10 to the 4th power times 10 to the 3rd power. So I have to have 4 tens times 3 tens. So real simple, just look at those exponents, and we're going to say that last option is the one we're looking for. We're going to say A is the 4th one. Then we have to have 10 fours times 3 fractions. So we're going to say that's going to be this choice B. So the first one is B. Then for C, we have 4 fractions and 3 tens. So that's going to be straight across again, is going to be C. And the last choice is going to be 4 fractions times 3 fractions. And so that's going to be part D. And so that third choice for C right here is the one we're going to do for our expanded form. So it says write 10 to the negative 4 power times 10 to the 3rd power as a power of 10 with a single exponent. So make sure you, again, same base. We're going to say that since we're multiplying, we add exponents. So we're going to say 10 to the negative 4 power times 10 to the 3rd power is the same as 10 to the negative 4 plus 3, which is equal to 10 to the negative 1 power. So make sure you can see how those are set up. Again, be sure to ask questions as they arise, and as always, super slam that subscribe button.